Good day, everyone. You are welcome to our online teaching series. Today we are going to be solving questions on resultant of vectors. The examples I gave to you in the previous slide, example 2.1, 2.2, 2.3. Example 2.1 is to be solved immediately after this class and sent to me 5 minutes after the class on my personal WhatsApp or my Gmail. Now, let's start. Example 2.1. Find the resultant of two forces, 10 Newton and 30 Newton, acting on an object at an angle 30 degrees to each other. We are given two vectors. We are given an object. Let's say this is an object O. Two vectors acting on this object. One acting, let's say, horizontally, 30 Newton. 30 Newton. The other acting at an angle 30 degrees to the 30 Newton. That is angle 30 degrees to the 30 Newton. And that vector was given to be 10 Newton. Now the question is, where will this object move? And if where will this object move, and what is going to be the force that makes this object to move? Is it the 30 Newton? Is it the 40? Is it the 30 Newton? Is it the 10 Newton? Is it the sum of the two forces? Is it the subtraction of the two forces? Now let's see how to solve that. Recall your parallelogram law of vector. Parallelogram law of vector says that if you have two vectors like this, then you see they are represented by the adjacent side of the parallelogram. Then the resultant is drawn from a common point. The common point, you draw a resultant. R is drawn from the common point. You can trace this 10 Newton to this side. Trace it. You see the way it is, the way it aligns, the angle it makes. Make sure you draw it exactly here. And that is your 10 Newton. So you can see I can have this 30 Newton, you can have it here. 30 Newton, 30 degree, you can have it here too. This 30 degree, you can have 30 degree here. And that is to tell you that corresponding angles are equal. Corresponding angles are equal. And if this place is 30 Newton, 30 degree, then the remaining angle will be 180. Since sum of angles on a triangle on a straight line is 180 degrees, it's going to be 180 minus 30, and that will give you 150 degrees. Now you are having a new diagram for this question. The new diagram you have for this question is going to be like this. This is your 30 Newton, and this is your 10 Newton. Your 10 Newton. Your 10 Newton. And this is your resultant R. Resultant R that you are looking for. That is the overall force that acts on this object O. The angle between 10 Newton and 30 Newton now is now 150 degrees. That is after we have transferred this particular force to this side so that we can form a good triangle. Now that we have done that, you can now use your cosine rule. Your cosine rule says that r squared, that is, apply your cosine rule using cosine rule. R squared is equal to 10 squared plus 30 squared minus 2 into 10 into 30 cos 150 degrees. Cos 150 degrees. And that is just to tell you that the angle that is facing R is 150. That is why we are using 150 for that angle theta here. And secondly, you see this is R cos 150. If the angle facing it is different, you use the angle directly. Now, you have R squared equals 10 squared 100 plus 30 squared 900 minus 2 times 10 times 30 will give you 600. Cos 150 will give us minus cos 30. Or better still, you just press your calculator and find cos 150 and it will give you a negative answer. That is 100 plus 900 minus Minus times plus will give you minus times minus will give you plus 600 into cos 30 will give us 0.8660. Better still, if you know you cannot do this, if you know you cannot remember all your trigonometry identities, you can just press your calculator and find cos 150. It will give you negative of this value, and that negative will affect the negative we have here to have positive. And at the end of the day, you will have 100 plus 900. 100 plus 900 will give us 1000 plus 600 times, let's do 600 times 0.8660, and that will give us 519.6. 519.6. 519.6. If you add the two together, you have 519.6. That is going to be your R square, and therefore you take the square root of both sides to have 1519.6. You take the square root of both sides, square root will cancel square, and you are left with this. If you find the square root of 1519, you will have R is equal to 38.98 Newton. 38.98 Newton. 38.98 Newton. If you find the square root, and finally you can say it's approximately equals to 39 Newton. That is just to tell you the magnitude of that resultant, the magnitude, that is the size of the resultant. We have not been given the, we have not solved for the angle or the direction of that resultant. You know, a vector must have both magnitude and a direction. Now it has a magnitude 39 Newton, but what is the direction? At what direction will this object move? And that is to find the alpha, that is the angle between the resultant and the horizontal force. Now let's do that. We can just use your sine rule. Recall your sine rule from sine rule. From sine rule, we say sine of an angle, sine of this angle, sine alpha all over the side facing it, 10, equals sine of this 150, that is sine angle of 150 all over the side facing it is the resultant. The side facing 150 is the resultant, and that is going to be 38.98. Now if you cross multiply, or you multiply both sides by 10, multiply both sides by 10, 10 we cancel 10, then multiply this by 10, you have sine alpha equals to 10 sine 150 all over 38.98. And that is going to give you, if you 10 times sine 150 is 0.5. Sine 150 is 0.5. Now 0.5 times 10 will give us 5. And if you divide 5 divided by 38.98, it will give us 0.1283. And that is your sine alpha. It implies that alpha equals sine inverse of 0.1283. And that will finally give us 7.4 degrees, approximately 7.4 degrees. And we can now conclude, therefore, the what? It implies that the what? The resultant of the two forces, the two of 10 Newton, and that is the resultant of the two forces we just mentioned above, two forces, is 39 Newton at angle 7.4 degree to the direction of 30 Newton. That is direction. We have already solved. We now see what we have already seen the effective force that this 10 Newton and 30 Newton will contribute to this object, which means it's not just going to be the addition, but this is the answer, 39 Newton. While the direction is going to be in this direction of what? 7.4 degree to the direction of 30 Newton. and that is your resultant. Let's move to the next question. Example 2.3. If Charles walks 30 meters due east, Charles walks 30 meters due east and 40 meters due north. Find A, distance covered by Charles from the starting point. B is displacement. So we have to solve the two questions. How do we solve that? Let's draw what we have. Let's see the diagram. We should remember our four cardinal points: your north, your south. If this is the point if this is the initial position of Charles, it has north, south, and it has east and west. Now they say this guy moved 30 meters due to the eastward, and that is, we have 30 meters due east. 30 meters. That is the first transition of Charles. The distance covered and everything. He walks 30 meters due east. This was his initial position, original position. So he walks 30 meters due east and 40 meters due north. He now move up. Maybe Charles was going to visit a friend. 40 meters due north, up, which means he turned. Now the first question is to find the total distance covered. A, distance covered by Charles is, let's call it S. This is just ordinary a scalar quantity. A scalar quantity, it has no direction, and that is going to give us the first transition of Charles, 30 meters, plus the second one, 40 meters, and this will give you 70 meters. No direction. The total distance covered by Charles is 70 meters. But for us to find the displacement of Charles from the starting point, this is the starting point. To find his displacement simply means, instead of going this way and going this way, can't he just move straight to his destination, which means you are looking for the resultant of Charles. This time around, resultant we are having there, which is called the displacement of Charles, is a vector quantity, and it represents the shortest distance between the starting point to the stopping point. So where he is going to, let's call it point X. And don't forget that for us to deal with a vector quantity, it must have both magnitude, which is your S magnitude, and the direction, let's say the direction towards the east, or the direction towards the north. If you get the direction towards the east, you can easily get the direction towards the north by subtracting from 90 degrees. You know, if I call this place alpha, the remaining angle here will be what? Will be 90 minus alpha, since the angle here is 90 degrees, right angle triangle. Then your east and north, they make angle 90 degrees to each other. So which make our new diagram to be in form of right angled triangle. Right angled triangle. Right angled triangle. And this is 30 meters. This is 40 meters. We are looking for is displacement at angle alpha. If that is the case, we can use Pythagoras theorem that says sine of the hypotenuse from your Pythagoras theorem, from Pythagoras theorems. From Pythagoras theorems, it says hypotenuse square equals to opposite square plus adjacent square. You can also develop this Pythagoras theorem from the previous example we did, the one we just saw. you can use that, using the angle to be 90 degrees this time around, and you will get the Pythagoras theorem. But we don't want to go through that again, and that is why I just need to use the Pythagoras theorem directly, since the triangle form is what? Right angled triangle. The hypotenuse is the side facing 90 degrees, that is s squared equals the adjacent, the opposite is the side facing 40 degrees, that is 40 squared. That is the side facing alpha is the opposite. This is the opposite of alpha. 40 is the opposite of alpha, and the last side is the adjacent of alpha, which is 30 squared. Therefore, s squared, or it implies that s squared equals to 40 squared, 1600, that is 1600, plus 30 squared, 900. And that will simply give you 1600 plus 900 will give us 2500, which is s squared. S simply means square root of 2500. If you square root of both sides, take the square root of both sides so that square will cancel square root. And this will give us 500 meter. This is the total displacement of charge from the starting point. This is the total displacement of charge from the starting point, which is the magnitude. This is the magnitude of charge. But how do we find the direction? Now, to find the direction, you can use your SOHCAHTOA. Your SOHCAHTOA, which means you can use your tan. If you like, you can use your sine too. If I like, I can use my sine alpha equals to opposite over hypotenuse, or sine or cos alpha equals to adjacent over hypotenuse. This is 50. Sine alpha, cos alpha is equal to what? Adjacent over hypotenuse. And tan alpha is equal to opposite all over adjacent. You see? You can see all those we have. We have this. So I can choose any of them to use. If you like, you choose your sine. If you like, I choose my cos. I choose my tan. Let's use our tan. Tan alpha equals the opposite. The opposite we know is 40 all over opposite, the side facing angle alpha. This is the adjacent, all over adjacent, 30. This is the hypotenuse. If you want to use, you can use this and we'll get the same answer. Alpha equals to, or let's see, tan alpha equals 40 divided by 30 will give us 1.333, and so on. And it implies that alpha equals to tan inverse of 1.333, and that will approximately give us, tan inverse of 1.333 will give us 53.12 degrees, or approximately equals to 53 degrees. Therefore, the displacement of charge, displacement of charge is 50 meters, instead of moving a distance of 70 meters from here to here. You just move 50 meters from here straight to this place, from the starting point to the destination. 50 meters at an angle, this alpha, at an angle 53 degrees to east, 53 degrees eastward, to the east direction. Or if you want to use bearing term, you will just go, if I want to use this, it means that the angle here is 53 degrees. And if the angle here is 53 degrees, the remaining angle will be what? 37 degrees. So if I want to use bearing term, I will say or at the direction of bearing, we say 90 minus 53, which is what? 37, which is going to be north 37 degree east, which means from north to east is 37 degree, which means instead of charge moving like this and like this, you just move like this, which is 50 meters instead of 70 meter. With this, we come to the end of today's